This is specifically the only IB criteria we haven't done is data collection and processing, and it's incredibly specific and incredibly obscure in my opinion. But let me just show you. First off, do we all know that every handout is on the website? Do we know that? Right? So it's like I didn't get the worksheet. Well, unless the internet was cut off, right? Imagine that you weren't terribly ambitious about trying to find it. So I'm going to click on the handouts here, and then I think it's, what is it? It's internal, it's a design. No, we don't want that one. We want, that's chapter 4. We want work and energy. Here we go. Okay. And it's a spring constant graph is what this is. Right? So the first thing is, the first aspect of data collection and processing, I'm going to give you a little sheet for this so that you can do this. But the first aspect is that you've got to collect data in an organized way. Notice that this graph, that the column headers have what it is. Then it's got, and they all do this, so I guess we better do this. They've got what the symbol for it is, and then what the units are. So S is what the symbol is, and I don't know why they use S, right? M is the units, and then the uncertainty of M is, since we knew we could measure millimeters, the rule is that it's half the smallest thing you can measure, okay? It's half the smallest thing you can measure. So this 0.0005 is half of a millimeter, right? Because a millimeter is 0.001, right? Isn't it? Correct me if I'm wrong. I think I'm right. I'm kind of bad at decimals like that, but I think that's correct. Okay, so that delta S is plus or minus whatever, right? And then what we're going to do is we're going to say that essentially can be ignored because we can't make a graph, an error bar that big. This one though, somehow we got the biggest, the smallest division was 1 Newton, so we're going to say we're half a Newton off, right? And so we estimated 1.6. It was a little more than half, but really we could be off by half a Newton either way, right? Obviously, I've sort of exaggerated that so we can make nice big error bars. Yeah? Okay. And you'll see. So, and then the second thing that you might not notice, and this is somewhat subtle, is that if you look at this, notice I'm giving 0.050. It was 5 centimeters is how far they stretched it, right? Why do they put the 0 on the end there? Because they measured that, right? So it's not actually sig figs, it's actually precision. In other words, if they stretched it to 1 meter and 5 centimeters, it would be 1.050, right? So it's not, they say sig figs, but I do believe they mean the correct thing is precision, right? That we know it down to the decimal place, right? If you look at this, obviously I could have written that 0.2 and this 0.15, right? But really we knew down to the millimeters, so that's important that we write down the precision. I could have written that just 6, not 6.0, right? But that would, you get dinged for that. You'd have partial on your first aspect. Right, is that you have to make all the sig figs line up, or not the sig figs, but the decimal points have to line up. Yeah? Okay? Then what we're going to do is we're going to make a graph, and you have to do exactly this, right? Of course the graph is going to be labeled with units and all this stuff, right? And we're going to put error bars on it, and then we're going to find, it turns out that a force versus distance graph, the slope of that is the spring constant, right? So we're going to find the slope of the graph, then we're going to find the steepest slope it could be, and the least steep slope it's going to be, and then you have to find the uncertainty with that. And nothing, you can't do anything else. That's the only valid thing for data collection and processing. And so that's both good and bad. Right? It's bad because there's way more things you can do in physics that are data collection and processing. It's good because that's the only thing we have to really learn how to do. There we have it. Right? So the first thing to do is to make a graph of this. And I was scoping this out, and I think we can make a decent graph of this with the graph paper I gave you. I think I've got a pencil over here. I don't have a pencil over here. I'm gonna have to find one. I think what I scoped out was what did I put my pencil? I sharpened a pencil. I even sharpened one in anticipation of making you. Oh, here it is. My sharpened pencil. Ticonderoga. It's a pencil. It's the best pencil in the world. Okay, I think what we want to do here, and I sort of scoped this out, I think we want to make, in the vertical scale, let's put the paper this way, and let's make our vertical scale, I think it works to make it half a Newton is a square, right? We're not going to use up the whole graph, so let's make our own axes here. There we go. Is that obvious? Oh, that's pretty obvious, isn't it? Right? Right, so now as we go up, every 2 squares is 1 Newton, 1 Newton, 2 Newtons, 3 Newtons, 4 Newtons. There's 5 Newtons. And that guy must be 10 Newtons, right? And this is, of course, force in Newtons. Okay, and then this is going to be stretch distance in meters, right? And then I think what I did was I made every, I think it's 0.01, right? So if we just go like this, I think this works. 1, 2, 3, 4, 5. 1, 2, 3, 4. There's 0.1, 0.1, 0, 0, right? 1, 2, 3, 4, 5. 1, 2, 3, 4. And that is 0.200, right? 10. Do I have to say 10.0? I think so, yeah. 1, 2, 3, 4, 5. Be one of those annoying people that keeps talking while you're trying to count. Right? Stretch distance in meters. Does that work? I think we can graph everything, can't we? Yeah. It's not going to be the biggest graph, but I couldn't figure out anything else. You guys are so talented and gifted, you probably will figure something out that would work. And now we want to graph the points. So the first thing to do is just make a nice dot where the points are. Oh, we need a title for the graph. What's a good title? This is something besides like Vincent, right? If you want to name it. How about force versus distance, right? For a spring, if we want to be like over the top. And the tradition there, by the way, is that you go y versus x, right? You don't need to label it that way, right? When you say it, it's y versus x. Kids always switch that around. There it is. Okay, so now we can plot points. 1.6. Let's see, 0.050. That's this guy here, right? 1.6. There's 1 point. 3.2. There we go. 4.5. Okay, 0.2, 6.0. Imagine my own children's joy when I played those same 2 songs